We're going to be talking about the counting rule for combinations. Now, counting rules are used to calculate the number of outcomes in an experiment. For example, the counting rule for multiple step experiments is used to calculate how many outcomes there are in a multiple step experiment. So here we're looking at calculating the number of outcomes in a specific kind of experiment. We want to calculate the number of outcomes when the experiment involves selecting lowercase n number of objects from a larger set of capital N number of objects. So the experiment is selecting a lowercase n number of objects from a larger set of capital N number of objects. So let's take a look at an example of this. Suppose that we're selecting two objects from a set of 5 objects. So lowercase n is equal to 2 and capital N is equal to 5. Now let's label the objects A, B, C, D, and E. So we have 5 objects labeled A, B, C, D, and E, and we want to see all the different ways that we can choose 2 of the objects at a time. So one way would be A, B. Another way would be A, C, A, D, A, E, then B, C, B, D, B, E, C, D, C, E, and D, E. So there are 10 different ways of selecting 2 objects from a set of 5 objects, and these are the 10 different ways. Now, to get the same answer, instead of writing out all the outcomes, we could use the counting rule for combinations. And the counting rule for combinations says that when we're selecting capital N number of objects from a lowercase n number of objects from a capital N number of objects, the total number of outcomes is capital N factorial over lowercase n factorial times capital N minus lowercase n factorial. So this is the counting rule for combinations. The number of different outcomes is capital N factorial over lowercase n factorial times capital N minus lowercase n factorial. Now, if you're not familiar with factorials, this is how factorials work. N factorial is going to be equal to n times n minus 1 times n minus 2 all the way to 2 times 1. So for example, suppose n is equal to 3. 3 factorial is going to be equal to 3 times 2 times 1, which is going to be equal to 6. And there's also a rule, if you ever want to compute 0 factorial, it's always equal to 1. So now let's return back to our example. We're selecting two objects from a set of 5 objects. And we want to see how many outcomes are possible. So using our counting rule and setting capital N equal to 5 and lowercase n equals to 2, we get 5 factorial over 2 factorial times 5 minus 2 factorial. So this simplifies to 5 factorial over 2 factorial times 3 factorial. Now let's look at how we can kind of simplify this calculation here. 5 factorial, we could write it as 5 times 4 times 3 factorial. And in the numerator, we have 2 factorial in the bottom, which is just equal to 2, times 3 factorial. So the 3 factorials cancel out. So what we're left with is 20 over 2, which is equal to 10. So there are 10 different ways of selecting 2 objects from a set of 5 objects, which is the same thing that we saw up here when we wrote out all the different outcomes.